Hello! In this video we will take a look at calculated data sources and how they allow you to get fast insights from complex data in mWater and Solstice. We will work through a number of examples that will showcase just how flexible this feature is. First, a few preliminary remarks. So, calculated data sources are basically pre-processed powerful datasets that make dashboards and data grids and consoles faster, smarter, and capable of handling complex analysis that would otherwise time out or not be workable in the platform. So because with calculated data sources you pre-process heavy data, dashboards load lightning fast. The trade-off is that it won't be real time, since you won't be calculating every change on the spot, but you can update these data sources with a schedule on a daily, weekly, or monthly basis, and you can also go to them manually and trigger a calculation when you want. With calculated data sources, you can combine multiple sources into one streamlined dataset and use that as the basis for your visualizations. And you can also solve issues where there's too much complexity and calculations in live dashboards either otherwise time out or are impractical to use. So let's jump right in and work through a number of examples. Okay, the four examples we will cover will be population served by water point, the percentage of functional versus non-functional water points by district, and the same could apply for functional or non-functional something else. Then an example combining different data sources that counts the amount of water points, schools, and health facilities by country recorded in the platform and visible to you. And then a more advanced example that takes an aggregate view and combines all of the population reached within 500 meters of each water point in a district. And this could be a school, health facility, or other map location instead at another distance from not 500 meters. So let's begin by our population served by water point example. We can go to our calculated data sources view here in the Manage tab of our navbar and click a new calculated data source to start the process. Let's give it a name. So population served by water point in Rwanda in my example. I can give it a description here, call it an example. So first we must pick the original data source. And here, since we are calculating the population within water points, we just pick the first available one here. Now, we don't want the whole world, we can just filter it to the region we're interested in this case, Rwanda. Note that you can filter by any element in the data, and by default, the maximum number of rows you get in your source table will be up to 100,000 rows. So we have our original data source. Let's start adding some columns. So this example will pre-calculate the population using the satellite population density information in the platform and calculate the right number for each water point in the country. So since our data source is a water point, we can pick from the data fields available there. We can pick the name, we can pick the unique ID given by the system. That makes sure we can identify that site. And then we create a formula that calculates the population within. So we jump over to the formula tab and click population within. We need two things. Population within what location? So we need to point this to the GPS location we've recorded for the water point or other type of site. And then we set the distance. That can be more, that can be less, but let's go with 500. We can just update the name here. This is already enough now to calculate the data, so we can preview it. And the calculation is done rapidly. We have a table of a name, unique ID, and population within water points, 500 meters for all of Rwanda. Next, we could order this data, for example, by the name, or date added, or organization, and we can keep adding columns as needed. Now then we can set a schedule Should this be run only manually from the calculated data source view, or do we have a weekly, monthly basis? We recommend not making it more frequent than it needs to be. Maybe since this is a national aggregate, a weekly update every Wednesday at 5 will be absolutely fine. And finally, we can set permissions. Who can edit this calculated data source, make changes to what we just saw, and who can view this, so pick it as a data source in their analysis. I could make it even public if I wanted the world to see this. Typically, I would choose an organization. Once we're ready, we can save, as long as we've calculated it first. So let's make sure we calculate this dataset. We are told that it's never been calculated and can't be used until it's been calculated. So we do this. Then we can create a data grid and pick this new data source from the calculated tab. Population served by water point in Rwanda. And we now have it as a data source. We save it, and we can now interact with it, filter it, do whatever we would like with it. So very powerful, simple example of pre-calculating something on a weekly basis. This was example 1. Next, example 2. Percentage of functional versus non-functional water points by district. So here we are just calculating the percentage of functional versus non-functional water points using the standard functionality indicator in the platform. So again, let's go to the calculated data sources view and click new calculated data source. Let's say the percentage of functional versus non-functional water points by district in Rwanda. I'll work out this example as we go. So then, again, we pick the site we're interested in. I know that the functionality of water points is recorded by default using an indicator that is linked to water points, so I will select that. But I do want to filter this for only Rwanda again. No limit and so on. So the first column, we want to pick the districts of Rwanda. That's what we want to disaggregate by. So I can go to location of the water point. Each time a water point's location is calculated, it gets aggregated into or determined which administrative region it belongs to. I can navigate the ones by country, and within Rwanda I see province, district, all the way down to village actually, but I'm interested in the district level. So I've navigated from the water point to the location, to the regions by country, found the one for Rwanda that I want, and in this case District of Rwanda. If you're working somewhere else, you can pick that instead. Now the next one is where we want to get a percent where water points are functional. Out of all water points, or in my case, all water points that have any functional data at all. So that I'm not making too difficult or too distant a determination. So I'm only going to consider the water points that have a functional status. Now, how do I get to that indicator I mentioned? I can add a column and go to related indicators. The standard functional indicator is this, water point functional status. So I select that, and once I've clicked it once, it appears here at the top of my indicator list, so I can easily access all the fields of data inside it. So I'm interested in functional data, great, but I'm also interested in being the percentage. So I will first go to the formula tab and select percent where to get the percentage. So percent where something of something. So percent where the status of a given water point, the latest status, that's what I'm interested in, the most current reality, is functional of, let's say, all of the water points where the functional status is not blank. That means it's not blank, there's some value there. So then what I'm getting is percent functional of water points with functionality data. Because if we don't have functionality data, I can't confidently say whether a water point is functional or not. It's just not been recorded. And again, we could order this data by, let's say, not the name of the water point, but why not the name of the district. So I navigate back to the Rwanda districts here. Now it's going to be ordered, and we'll set permissions, frequencies, and so on. Frequency can be daily, weekly, monthly, but at this high district level, I would imagine having it at on a weekly or monthly basis makes most sense. And here we go, quite high functionality rates for some and quite low for others. We get a lot of detail here. We can round that in our display when we actually get to displaying this on a map, for example. So now I can save this. Once I've saved it, let's calculate it, and then we can use it in a data source. So then we could go to a dashboard, create a new dashboard to visualize our results. And we can do it in any number of ways, on a map, in a table. I will use a chart to make a comparison easy. So I can use a bar chart and then go to calculate it, pick my new data source. The horizontal axis will be the district. Let's change it this way. And instead of the default number, I want to get the percentage functional as a rounded decimal. Maybe make the color more appealing still. And they're lightning fast, pre-calculated. Oh wait. I need to divide that by 100. Okay. Because it's multiplying it by yeah, great. And if I want to see it in more detail, I can use a percent decimal. So here we learned how to aggregate data by district and using an indicator into a lightning fast data source. That was example 2. Let's move on to our third calculated data source example, which is combining data sources so that we get a list of water points, schools, and health facilities by country. Let's go to create a new calculated data source. From the Manage tab, click New Calculated Data Source. Say country summary of water points, healthcare facilities, and schools. Now, we won't pick a water point, school, or health facility as our data source. We will pick countries. So here, that means we can pick from advanced the administrative regions themselves as a data source. So this is asking the database, hey, can you bring me all the administrative regions that you have in your database? Great, well that's a good starting point, but we're only interested in the country level. This is a country summary after all. So let's make this filter limit to only countries. One way to do that is to select the level in the hierarchy to be country. So what does this mean? Well, the administrative boundaries in the platform start at the country level and then have various levels underneath them. In some countries, they might be called regions, provinces, whatever, and then districts, towns, cells, villages, whatever they are. So those are just called level 1, 2, 3, 4, 5. But I'm only interested in the country level in my example, so I add a filter that says I'm only interested in those administrative regions that have been marked to have a level of country. So this will now already give us a list of countries. Great. Let's make sure that's always ordered with an order. Next, we wanted to get the water points, healthcare facilities, and schools. So 3 more columns. How do we do this? We add a column and then we use an advanced formula known as a subquery. So this is the formula you want to use whenever you want to query another data source entirely and connect it through some shared dimension of data. So because I know that each water point has a location and a location in the platform gets assigned into an administrative region, I can then compare and say, okay, well, for this country, how many water points have you determined to be in this country? So therefore, in my first column for water points, I use a subquery expression and a water point data source. Now this is an advanced interface that it's worth studying a little bit. We have a couple of components, reference to an outer query. So this is what we pass through from the original data source. In this case, it should be the country, right? So when we're going through our whole table of over 1 million water points, we have at hand the country we're comparing against. Does this water point belong in this country? Yes, no. So therefore we pass in the ID of the administrative country. We could pass the name, but name checking is much slower. At the database level, the ID makes sense. So we're passing the ID, the database name of the administrative region. We are calculating the number of water points, and this is the critical step. If I do just this, all I'm doing is calculating the total number of water points in the world in the database. I want to filter it to only this country. You can imagine that the system is going through every country, and then for every row of the country table, it's asking all the water points, the 1 million water points. Which country do you belong to? Is it this one? So therefore, we have to take the administrative region of the water point, wherever it is, and use the is within operator, so it understands the nesting. And then we see that there's this variables tab. And what is this? This is the country we've passed in from the outside. So this is effectively saying, is the administrative region this water point belongs to within the country that we're looking at? Is the water point and the administrative region it belongs to within administrative region we're looking at? So is Lira within Uganda? Is Addis Ababa within Ethiopia? So that just gets labeled subquery. We call it water points. Okay, so now we can preview. Let's see what happens. Wow, fast, and now it's ready for you to use. And you can see what's going to happen next. We're going to create a subquery for practice for healthcare facilities. Subquery using the healthcare facility site. We're passing in the administrative region of our country table. Could be district, could be region, whatever. We calculate the number of health facilities, and we absolutely crucially do this filtering step. We check which administrative region the health facility is in and compare that against the one we're passing through from the table. So in this case, the country. And finally, again, the same thing for schools. Subquery, school, administrative region, number of schools, and we are comparing the administrative region being within the country. Call it schools. Then we can set any other ordering we might want, school name, number of water points, for example. But then we need to recalculate that. Do we want to have a schedule? Monthly? Yes, let's say monthly, 10 o'clock on the 25th of each month. And then share permissions if we want, who can administer, who can view. Let's save this. We get back to the list of calculated data sources, and we're told that we must calculate this before it's available. Let's calculate it, and then let's go build or view a little table on the basis of this. Great, 10 seconds, and now it's super fast wherever we use it. Let's go to data grids. Go to calculated and pick the example, calculated the country summary. And there we go. I have a country level summary. So this, you can imagine using this for all kinds of country level aggregation, for filtering to your accomplishments. Let's say you want to do a global dashboard of what your organization achieved. Easy peasy with the subquery and a good data structure. Now, finally, let's move on to example 4, where you can hold on to your horses because it's one level more advanced still. Here we will do an aggregation. So we will look at how many people are within 500 meters of any water point inside a district. So we'll do an aggregation using a nifty combination of some features. So we go to calculated data sources here, create a new one, and say population within reached within 500 meters of all water points of districts in Rwanda. So here, let's see if we can manage. We pick as our data source, again, administrative regions. So this way we can list out all the districts of Rwanda, if we do it correctly. So we can say that we're interested in only the ones where the country is Rwanda and the level is 1 or 2 levels below. Let's say 1 level below. We could limit it to an individual district as we please, or different level, different country, of course. So if we pick the full name, we'll see what we get. These 5 are these districts of Rwanda, whatever the level is below the country level. And then we want to calculate how many people we think live there. We can use the population within formula and configure it to say, well, okay, within the shape, so this is the whole shape of the Rwanda country and district, and we use this trick to say distance is 0. So everything that's exactly within that shape. So this should start calculating population based on the satellite information layer. Simple so far. Now we need to create what's the total population within 500 meters of any water point within those districts without double counting. So we want a population within, so we start with a population within expression or formula. Now it gets a bit more complicated. We want to choose the overlap for our location, not just our basic overlap, but use one of the more recent geospatial expressions of the overlap between shapes. So what is the part of 2 shapes that overlap? So we're only interested in water points that are within these districts. So we want to check between the overlap of the country itself or the district itself. So in this case, the shape of any given administrative region we're comparing. So in our table of districts, we pass in the shape and compare it to the location of the water point. Well, how do we get to that? We put another formula. We call it the spatial join formula. And this we can configure to go from the shape. So this is the list of districts again. And the 2 is, well, in this case, it's water points, my favorite example. We pick the location here. And then to get the calculation, we'll want to actually merge the shapes. So yet again, we nest another mate feature. We merge all shapes to the aggregation table. of the GPS location if we expand it. So we add another formula, we expand the location, so the point of the water point, we expand it by our target 500 meters, and we combine them all together into one big shape. This is why we're using the merge all shapes formula. So this now does it, but only for the ones that are within our administrative region for each row of the table. So we're only interested in Rwanda and only interested in the districts inside. We don't need to have any filters, but we then, since we're doing the buffer, we just put it within a distance of 0 meters. So that was a lot. One recap, we're using a spatial join to join data from two different data sources. The original one is our administrative region table. We've filtered down to this district of Rwanda. And the target one, since we are looking for the population falling within 500 meters of water points, is to merge the shapes that have been expanded by 500 meters. So this creates a circle of 500 meters for each water point, and this merge all shapes formula combines them into one shape. So that means that we're not going to be double counting, because we will be looking at the population that falls within this complicated shape of a merge of all of these circles. So here again, it's just exactly what falls within that distance, so it's 0. Maybe that'll work. Population parameters of a water point. Okay, so we can save this. Look at the other details later, and this has never been calculated. This might take a little while. It is going through thousands of points, millions of dots on the map of population density, and it does take 8 seconds. Great. So now we should have a quick preview as well. 8 seconds. So we get a value of how many people, based on the data available to me and visible to me, of how many people are reached with water based on the data by that. So we've achieved our goal. We could then add an ordering, add a schedule, add permissions, who can view, who can administer, and set it off. So now we could go to a data grid as well to use it in any of our data grids, consoles, dashboards, maps, and just pull that from the calculated tab. Add them, and then have them available here. And now we could, of course, do stuff like add a column where we compare the two. Add the multiplier by 100. So assuming we have a comprehensive view of these water points, this ignores water systems, pipe systems, and everything, this approach, but you could expand this example to sum and merge both water points and systems if you want. So given all of this, very powerful example. Hopefully these 4 examples give you a sense of just how flexible and powerful these calculated data sources can be. Personally, I'm finding new uses for them just about every week, and know that there are many, many more things that they can do. So hopefully this will be very useful for you as well in your more advanced use cases. Now, if you have feedback on this feature or have advanced questions, please feel free to contact us. You can look at the video notes for contact details or leave a comment. And keep spreading the word about our platform. That means that more new features will come online that will help you further. Thanks for watching, and please have a great day.